Hola, me llamo Señor Blanco y vamos a estudiar las funciones circulares. Don't worry, I'm not going to keep doing that. But put your calculators away and consider the following questions that you see on the board right here. We're going to be getting into some rather difficult material here. This is where the mountain starts to get a little bit steep and where you really need to be diligent about getting your questions answered before allowing yourself to fall behind in this content. We are going to start getting into some of these abstract concepts that you see here on the screen. We're eventually going to figure out what does the triangle look like that has a side length of 0. That's the only one that we're not going to get into today, but all the rest of these, we're going to have to start using our imagination here a little bit. I'm going to introduce a number of vocabulary terms here today, and hopefully you'll find that just based on your understanding of the English language, you'll find a lot of them are fairly intuitive. But I do ask that you turn to page 372 in your book, assuming we're still using the 6th edition of our pre-calculus textbook with the green cover. And that's where you'll see these vocabulary words highlighted. And rather than have you just read that page and try to understand them by reading that page, I do ask that you try to follow along, kind of skim it over, and then follow along and see if this video helps correlate with what you read on that page. All right, first let's take a look on the XY plane and get a sense of why the quadrants are numbered the way they are. I find that most students come to pre-calculus knowing that the quadrants are labeled 1, 2, 3, 4 in the manner that I'm showing here. But I find that most students don't know why they're in that order. Why don't we just do it from left to right like we're reading a book? Well, the reason is because this is the order in which angles sweep through the XY plane in a positive direction. So here's what I mean by that. If I take this angle, start sweeping it through the quadrants here, you notice that they go in the order of quadrant 1, and then it proceeds through quadrant 2, and then quadrant 3, and finally quadrant 4 before just going through that cycle again. 1, 2, 3, 4. Now you'll notice a couple things here. I started at a particular place. I started along the positive x-axis. I didn't start measuring or start moving from here, 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 or anywhere else. I started from here, and that is because in standard position, which is what we're always going to be using in this class, when you measure an angle on the xy plane in standard position, you will always start from the positive x-axis. And because we are starting there, we will call that the initial side of our angle. Now, as I move through, whether I move through in this direction or the other direction, wherever I end up, that would be called our terminal side. So there's an initial side and a terminal side to each angle. And notice that I was moving in the counterclockwise direction. And I was calling that, and I refer to that as a positive angular motion. So when you move counterclockwise, that means you're going to get a positive angle. Whereas if you start at your initial side, the positive x-axis, and move clockwise, that would give you a negative angle. Now, whichever way you go, positive, negative, degrees, radians, whichever way, when you end up at your terminal side, whatever angle you end up with, and again, whether you're dealing with a positive angle measurement or a negative angular measurement here, you call that the measure of your angle. And finally, the corner, this one hopefully is familiar to you, the corner of your angle is called the vertex. And yes, it will always be the origin. The vertex will always be at the origin in our standard position. So again, it's a lot of vocabulary words to throw at you, but I hope they all seem logical and make a certain amount of sense, just intuitively. All right, let's go to our first example, finding coterminal angles. And that is an additional vocabulary term, which may not be quite as intuitive, but I do ask that you think of it from an English point of view. I have to admit, knowing a little bit about English is a little useful here, for co and terminal. And think of other words that have the prefix co, and think of what terminal means, terminate, terminal. And that will give you a clue as to what coterminal angles are. So let's start with part A of this example. the negative 150 degrees, and we're asked to find and draw a positive angle and a negative angle that are coterminal with the given angle. Well, we first have to start by figuring out where that given angle is. So since my angle of negative 150 degrees is a negative number, I am not going to move counterclockwise in the positive direction. I'm going to move clockwise in the negative direction. Doing so, I move past negative 90 degrees right here, but I stop short of the negative 180 degrees right here. So again, this is negative 90 degrees, this is negative 180 degrees. And so let me just draw that there. Negative 90 degrees, negative 180 degrees. And I ask that you try to draw, don't just, on your paper, don't just draw it anywhere in this quadrant. Try to draw a reasonable approximation. If this is negative 150 degrees, that means it should be 60 degrees past negative 90 degrees, right? Or I guess I should say negative 60 degrees past negative 90. And that means it should stop short 30 degrees from the 180 degree mark, right? So try to draw that accordingly. Don't draw it like this or like this. Try to draw something that looks like a reasonable negative 150 degrees. And I will label that here negative 150 degrees. That's our given angle in the third quadrant. Just to reduce the clutter here, I'm going to erase these two. And our first assignment here is to find a positive angle that is coterminal with the given angle. So since I want a positive angle, I will move in the counterclockwise direction. I'll move past 90 degrees, past positive 180 degrees, and I'll keep going. And do you recall how far past I have to go? Remember how we said that this little sweep here was 30 degrees? So if I'm at 180 degrees right here, positive 180 degrees, I'll keep going an additional 30 degrees, and that'll bring me to positive 210 degrees. Another way to look at that is to say I'm going to start with my negative 150 degrees, and I know that I can do a full circle in either direction and end up at the same spot, right? For any angle on the xy plane, you can always do a full circle in either direction and terminate at the same spot, aka get a coterminal angle. So that means I should be able to add a full circle of 360 degrees, and that will give me a positive coterminal angle. And sure enough, negative 150 degrees plus 360 degrees does give me positive 210 degrees. That is our positive coterminal angle. And similarly, to get my negative coterminal angle, I am essentially going a full 360 degrees in the clockwise direction. And similarly, just in terms of arithmetic, I can take negative 150 degrees, and this time I can subtract 360 degrees. And that would give me negative 510 degrees. I don't know about you, my mental arithmetic is pretty good, but I don't really feel like dealing with these big numbers much longer. And that's why I'm going to make a case for radians in the following lessons, why I think radians are actually easier. I should point out, these are not the only answers. There are really an infinite number of coterminal angles. We could stop here, just to be clear. We have satisfied the question, but there's no reason that I couldn't add an additional 360 degrees and get another positive coterminal angle. Well, that'd give me 570 degrees. And again, I find dealing with these bigger numbers is really just less convenient than dealing with radians. Likewise, I could take that negative 510 degrees and I could subtract another 360 degrees and get negative 870 degrees. So again, all these angles that have boxes around them are all considered coterminal. One last point before I move on here is that we would not say these are equal. I find students trying to say, oh, so Mr. White, negative 150 degrees is equal to 210 degrees? And the answer is no. In the same way that just the number negative 150 is not equal to the number 110, we would not say they are equal. That's why we have this word coterminal. They are coterminal. All these angles are coterminal with the original negative 150 degrees. Okay, hope that's clear. Just to keep this video from going on forever, I've worked out part B here. I hope you'll pause this and take a look at it and see if you agree with my answers there. Let's go on to part C. This time we're working with radians, and I'm going to do something a little bit unusual here. I'm going to find that I find it's easier just to get rid of that y-axis. And the reason is because we know that when we're dealing with radians, this would be 0 radians, and this would be pi radians. At least we should know that very well by now. And if you remember my half pizza analogy, I'm going to take this upper half pizza here, and I'm going to cut it into 7 equal slices based on that denominator. Don't worry about the numerator yet, let's just focus on the denominator. That's what tells us to take this half pizza, and I'm going to do my best just to eyeball it here, or freehand, call this 7 equal slices. At least for freehand, I'll call that acceptable. And I'm also going to do that for the bottom half of the pizza as well. You'll see why in a moment if it's not already apparent. I'm going to cut that into 7 slices that are intended to be drawn as equal slices. And the reason is because each of those slices has a measure of pi over 7. So I can say that this first one has, in standard position, has an angle measure of 1 pi over 7. This would be 2 pi over 7, and so on. If I really want to continue that pattern, I can even call pi itself 7/7 of pi, and it becomes very easy to see that this is 8 pi over 7 down here, and therefore my angle that I have here is located there. All right, so for the first part of this request to draw a positive angle that is coterminal with that 8 pi over 7, I would simply need to take this 8 pi over 7 itself is already positive, but if I continue going in the positive direction, 9 pi over 7, 10 pi over 7, 11, 12, 13, 14 pi over 7. That makes sense because 14 pi over 7 reduces to 2 pi. Makes sense. 15, 16, 17, 18, 19, 20, 21, 22 pi over 7 represents a full round trip, and so I write 22 pi over 7. This is a coterminal angle, and similar to what we did in the last case, I can look at it from an arithmetic perspective and say that if I take 8 pi over 7 and I add a full 2 pi radians, that would give me a coterminal angle. Well, if I'm going to add fractions here, I need to have a common denominator, right? So I'm going to do this fairly quickly. I hope your fractions are up to snuff here. If I have 8 pi over 7 plus 14 pi over 7, 8 plus 14 gives me 22 pi over 7. That's just some fraction addition here, and it corresponds to my answer that I got a moment ago. All right, going in the negative direction, that would be 8 pi over 7. I'm just going to jump to the arithmetic form of it here. That would mean going clockwise, right? A full turn, and that's the same as subtracting a full 2 pi times 7 over 7, right? And if I did the same fraction addition or fraction subtraction in this case, that would give me negative 6 pi over 7. That is our negative coterminal angle. And hey, that actually makes sense because if I started at 0 and went negative 1, negative 2, 3, 4, 5, 6, I would end up at the same place, coterminal. I hope that makes sense. Let me show the next example. And again, just to keep this video from going on forever, I hope you'll pause this, look at it, and say, yeah, you know, that actually makes sense. Let's have you go ahead and try some on your own. You know how to do this. Pause the video. In just a moment, I'm going to show the solutions. Okay, let's get to the solutions here. And there they are. And I'll repeat that there are an infinite number of coterminal angles. You could have, you know, different answers than mine as long as you have one positive and one negative, and that they differ by some multiple of 360 degrees or 2 pi radians. All right, let's go on to our last example here. Evaluating trig functions on the xy plane. Let theta be any angle in standard position whose terminal side contains the point -5, 7. Those are x and y values. Find the 6 trig functions of theta. So if I go onto my xy plane and I draw -5 over and 7 up, once again I ask that you draw a reasonable drawing. This length here should be less than that length there. And I'm going to draw a hypotenuse here. Now, as far as the length of the hypotenuse, I hope it's clear that the Pythagorean theorem is going to be the key to finding that length. So square root of 7 squared plus -5 squared would give us, let's see, 74, square root of 74. So notice I did something kind of odd here. I labeled this triangle with a negative side length. Of course, when you look at it, we wouldn't really say that length is -5, but we're using our imagination. We're recalling that we are on the xy plane, and hopefully with that, in that context, it makes sense to call this -5 and this +7. As for the hypotenuse, get this down now. Students always ask me, no matter how many times I say it, please get this down now. Hypotenuse is always going to be positive. I'm not going to try to explain why right now in the video. I just ask, this is a rare case where I'll say, please just believe me, we can talk about it later if you like. But the hypotenuse value will always be positive, even though the opposite and adjacent sides may be negative. All right, so speaking of opposite and adjacent, when you look at this picture and you ask yourself, which one's the opposite and which is the adjacent? I know this is my hypotenuse, but you're always taking the perspective of somebody standing at the origin there. So pretend that you're standing there at the origin or the vertex of the angle, and notice that this would be our opposite, this would be our adjacent. So opposite, adjacent. And likewise, I want to point out that the x value, when you're given point coordinates, the x value is always your adjacent side, positive or negative. The y value is always your opposite side. So that's a connection. I don't want you to simply memorize that. I hope that when you draw the picture that just makes perfect sense. Now, to keep this video from going on any longer, I'm going to put the trig functions up here. And I hope that in looking at the diagram that we came up with and in looking at those trig functions and your understanding of SOHCAHTOA and such, I hope that makes sense. The one thing that I could see here that may confuse you a little bit is that you may be looking at, let's say, the cotangent, for example, or no, let's say the secant, for example, and say, isn't secant supposed to be hypotenuse over adjacent? So shouldn't it be positive root 74 over -5? And I would argue that you can put the negative down here if you want and make it positive up top. That's fine, but I just find that looks a little strange. And hopefully you know that with fractions, you're free to move that negative sign. You can keep it up here. You can put that negative sign down below, or you could put that negative sign out in front if you prefer. Various ways you can write it. So just get used to seeing that move around. All right, again, I know I went through this one really quickly to try to keep the video from getting too long, but study that as much as you need to and try this on your own, please. I will be revealing the solutions in just a moment. All right, solutions coming up. There they are. Those are the pictures you should have, triangles in quadrants 3 and quadrants 4. One thing I realized I forgot to mention, and I hope this didn't screw you up, is that you should always draw, I think I've mentioned this in class already, I should have, but you should always draw your triangles when you have an angle in some quadrant. You should always draw vertical lines to the x-axis to complete your triangle, making a bow tie shape if you were to draw angles in all 4 quadrants. You should never, ever, ever draw horizontal lines to the y-axis. That will never happen in this class. All right, so with those pictures, if I move those out of the way and put the solutions up here, they should look something like this. Again, there could be variations on this. You maybe rationalize the denominators, or maybe put the negative sign in a slightly different place. But other than things like that, hopefully these agree with your answers, and if not, come by and see me during office hours.